Okay, welcome back. In this video, I'm going to describe how the graphs get made for the trig functions. Well, just 10, and the rest are kind of similar. Let's see, so I'm going to activate my laser pointer. All right, so what's going to happen here is there's an animation that shows this yellow bead moving around the unit circle. The red part of the diagram, this red arrow here, that's the hypotenuse of the right angle triangle that's constructed. The purple is the adjacent. The green is the opposite. Okay, and then the orange tells you what angle is currently being used. Okay, so I'm then going to construct the ratio of the green over the red, so the opposite over the adjacent, to create the graph of the sine function, which is in green on the right hand side. And I'm going to use the ratio of the purple to the red, so the adjacent over the hypotenuse, to construct the graph of the cosine function. Okay, so I'm going to let it go a little bit, and then I'm going to hit pause right, and when they cross right there at 45 degrees. So at 45 degrees, what happens is the opposite and the hypotenuse, the opposite and the adjacent are the same. They have the same length. So the opposite over the hypotenuse is the same as the adjacent over the hypotenuse. In terms of constructing that as an xy coordinate in the graph, you can see that's where these two functions cross. The sine of x equals the cosine of x at pi over 4. So that's a nice feature that's just highlighting that. The graph will keep going. Okay, and now I'm going to pause right before it, right there. Okay, I'm going to pause right here. Now look what's happening with the sine graph. The sine graph is hitting its maximum. What's going on the left, on the unit circle, is that the adjacent shrinking down to 0, but the opposite is coming very close to overlapping with the hypotenuse. Once the opposite overlaps completely with the hypotenuse, we're going to have hypotenuse over hypotenuse. We're going to have 7 over 7, or 1 over 1, or 2 over 2, whatever it is. We're going to have a length of 1, or a ratio of 1. The ratio can never be higher than that. We can never have an opposite or an adjacent that are larger than the hypotenuse, because that doesn't make any sense. The longest side of a triangle is always the hypotenuse. Now, what happens in the purple is we'll look at the graph of the cosine function. In purple there, that little dot is getting close to a y-intercept of 0, that little purple dot. Now if I unpause this, so there it keeps going. Now hold on. Another comment is look what's happening to the sign of the graphs. And by sign I mean the plus or the negative. The cosine graph now has a negative y value. The sine graph still has a positive y value. What's going on is sine is opposite over hypotenuse. The opposite, the green, is still in the positive y direction. The purple, the adjacent, is in the negative x direction. So it's the purple's negative. Cosine is purple divided by red. It's the adjacent divided by the hypotenuse. So it's a negative quantity, and that's being shown by the cosine function becoming negative as we moved into the s quadrant. So the graph is following the cast rule. We keep going, and the cast rule says that as we go into the t quadrant, sine and cosine both become negative, and that's what happens. Now the green function is in the negative y direction because our opposite is negative as well. We haven't left the negative y direction for the cosine function because our adjacent is still negative. Now let's see what happens as we approach 270 degrees. Approach 270 degrees, there's both still negative y, but now the cosine function is getting closer and closer and closer, and boom, at 270 degrees, the adjacent has scrunched down to nothing. So the cosine function is 0 divided by whatever the hypotenuse is, which is equal to 0. And as we keep going, we're now going to be moving in the positive x direction. The adjacent becomes positive. So the cosine function switches back to being positive. The sine function is still negative because it's still negative y direction for the opposite until we hit it's back to 0. We go back to 0, now the loop is going to just repeat. We're going to repeat that process. Both functions will be positive y direction. It'll just loop and loop. So that's the connection between the cast rule and the graph of the sine and the cosine function. Yeah, it's really important. Hypotenuse is, by convention, always accepted to be positive, no matter where the angle is, no matter what quadrant the angle is in, but we allow the opposite and the adjacent to become positive or negative, depending on whether they correspond to a negative or positive x or y direction. That entirely defines whether the sine graph or the cosine graph will have a positive x or a positive y or negative y. So I know it's a little bit confusing, isn't the best, isn't probably the best explanation out there, but this is the best I can do as an explanation for where the graph of the cosine function and the sine function, how they're connected to that cast rule. Okay. And it's probably best to stop this and continue on a new video.